Hello, my name is Dr. Coca, and in this video we're going to be finishing up the Tetrazole experiment. So we previously ran a reaction with a nitrile and sodium azide in a microwave, and then we ran a TLC to make sure the reaction has proceeded to give us a new compound. And then at this point we're going to purify our product by doing an extraction. We have here the reaction, a vessel containing hopefully the product. To this reaction, we want to, or this reaction, we want to transfer that over to our separatory funnel. So we can pour the contents. I can shake it up a little bit. Pour the contents into the separatory funnel. And then we want to use sodium or saturated sodium bicarbonate in water to help with the transfer. So we are going to add approximately 5 milliliters. Transfer that over. Repeat it a second time. And then we're going to use, or we're going to add about 5 to 10 milliliters of ethyl acetate. I'm going to use the squeeze bottle for that. And if we place our stopper on top of the separatory funnel, shake it a couple of times, want to vent it away from us into the hood. And then we want to let it sit for a minute or so. So this allows the two layers to separate. So depending on which nitrile you start with, you might have different colors. So some are yellow or darker in color. So you might actually see some colors within the layers. So in this case, it's actually a fairly colorless solution on both layers. After we let that sit enough, we can then do a separation. So I have 3 Erlenmeyer glass that I have labeled 1, 2, and 3. And we're going to take our lower aqueous layer containing sodium bicarbonate, which is the base, and also if there's any tetrazole in the reaction, it should be in the aqueous layer as well. So we're going to open the stopcock and pour the contents into the first Erlenmeyer. And now we have remaining the organic layer. We want to put that into our second Erlenmeyer. So the organic layer should be mostly ethyl acetate, and if there is any unreacted nitrile, that would also be in that organic layer. So this first step in the extraction separates the nitrile from our tetrazole product. So we can repeat this extraction a couple of times to make sure we get all of the tetrazole product out, but I'm going to move ahead and to the next step, which is now recovering our tetrazole product. Here is hopefully our tetrazole in the aqueous layer. So it contains a lot of sodium bicarb, which I mentioned is a base. To it, we're going to add 6 molar hydrofluoric acid. And we want to do this dropwise. So as we start to add tetrazole, 6 molar ACl, you might notice a little bit of precipitate forming. Okay, stir it, we can definitely see that the solution has turned cloudy as precipitate forms. Another thing that happens here is we're going to see some bubbles coming out of the solution because ACl is neutralizing sodium bicarb. The byproduct of this neutralization reaction is CO2, which is a gas, and it'll just simply escape out into the atmosphere. We want to make sure we add enough ACl. So at the beginning, I'm always very careful, but after a while, you don't have to be as careful, and you can clearly now see that there is a lot of precipitate. I'm going to add one more pipette full of ACl just to make sure it's acidic. And one good sign that it's acidic is the fact that you see a precipitate. So that precipitate should be our tetrazole product coming out of solution as you neutralize the base and also add enough protons to turn the tetrazole back into a non-water soluble structure. It is no longer soluble in the water, so it forms a precipitate. It's mostly aqueous layer. So we want to confirm the fact that this is acidic, and one way of doing that is by using pH paper. So you can either grab a spatula or a pipette and just grab a little bit of this solution and touch a pH paper. So if we do that, you'll notice that this pH paper turns sort of a purplish color, which according to this is around 1, somewhere in between 1 and 2 as far as pH. So that was where we wanted to go. So this is acidic enough that we can move on to the next step, which is to recover the tetrazole out of the aqueous layer. So we can now take this tetrazole in mostly an acidic aqueous solution, pour that back into the separatory funnel. So it's a good idea at this point to wash your separatory funnel before you pour the contents back, but just for the sake of this demonstration, I'm going to just continue to use the same separatory funnel. So we're going to pour our tetrazole product into the separatory funnel. We want to grab fresh ethyl acetate, and I'm going to use it actually to rinse our former aqueous layer that was in Erlenmeyer number 1. Pour that into the separatory funnel. Do this a couple of times, maybe one more time. So overall, we want to use maybe about 10 milliliters of ethyl acetate to transfer our product into the separatory funnel. So you can see that the lower layer is fairly cloudy, the top layer is mostly clear. If we start to mix the contents and vent it, do this a couple of more times, get the two layers to mix. You can start to see that the aqueous lower layer is now clear, and the product has migrated to the top layer and is actually dissolved in the ethyl acetate since it's an organic compound at this point, and is going to be soluble in this in the ethyl acetate. So if we let this sit for a few seconds, let the layers separate, we can now pour the contents of, well, at least the aqueous layer into Erlenmeyer number 1. So remember, that's where our previous aqueous layer was. So we can just pour it back into there. then we can take our top layer, which is ethyl acetate and our tetrazole product, into Erlenmeyer number 3. We want to make sure that we get all of our product out of Erlenmeyer number 1. We can pour the contents back into the separatory funnel, rinse it with another 5 to 10 mLs of ethyl acetate. Mix the layers, vent it, kind of let it sit, let the layers separate again. This is what it looks like right now. So the layers actually are separating still. There's sort of an emulsion in between them, but now it looks fairly good. We want to remove the aqueous layer once again. So that's the lower layer. We want to pour that back into Erlenmeyer number 1. And then once again, the organic layer, we want to add that to Erlenmeyer number 3. So this is where we placed our first extraction with ethyl acetate just a moment ago. And we're going to do now our second. We're going to pour that into the same Erlenmeyer flask. Okay, so this is the organic layer after 2 extractions of the acidic aqueous layer. We still have Erlenmeyer number 2, by the way, which contained the original ethyl acetate with the unreacted nitrile. That we kept separate. We don't want to combine that again with our tetrazole. So now in our now we have in Erlenmeyer number 3 our product. We want to dry this with a little bit of sodium sulfate. So if we add tiny amount, maybe about 100 milligrams of sodium sulfate into our organic layer. Let it sit for about 5 minutes. This should be dry enough. It should the sodium sulfate should pick up any traces amounts of water that are remaining in that organic layer. And at that point, after 5 minutes, you want to transfer the organic layer with the tetrazole product into a new flask, so a round bottom flask, and that is pre-weighed. And then we take our round bottom flask on a rotovap. The rotovap will get rid of the solvent, the ethyl acetate, and leave behind our solid product in the round bottom. And then we subtract the weight of the round bottom flask, and we'll have the weight of the tetrazole. And we can, from that, determine the percent yield. After we allow the product to dry long enough, we can take a melting point. We could do an IR, and we could possibly do an HNMR or C13 NMR, just to confirm that we have our product, and also confirm which tetrazole we have in this reaction.